So here I had given the summary. Let us assume 0 initial conditions. So in many applications, we will assume the initial conditions are 0. So if you assume the 0 condition means, then it means you are ignoring the second part of the equation. So then the resistor can be represented via capital V of S is equal to R times capital I of S. So this is the equation 1. An inductor we can represent like this: capital V of S is equal to S times L times capital I of S. S is the complex number, L is the inductance value, I of S is the current flowing through the inductor. So this is the equation number 2. And the capacitor, voltage across the capacitor V of capital V of S is equal to 1 divided by SC capital I of S. This is equation number 3. So you should remember these 3 equations. These 3 equations are very important. So voltage across the resistor, inductor, and capacitor. So R I of S, SL I of S, 1 divided by SC I of S. This is for 0 initial conditions. And what is the impedance? So we can define the impedance in the S domain as Z of S is equal to V of S divided by I of S. So this is the same standard formula. Impedance is equal to V by I, right? So just we are representing the same thing in terms of, this is the time domain. So I simply write Z, it means Z of T is equal to V of T divided by I of T. So the same thing I represent in Laplace domain or S domain. Z of S is equal to V of S divided by I of S. So this is just based on the Ohm's law. We know Ohm's law, V equal to IR. So here R is equal to V divided by I. So here R we are representing in terms of, instead of resistance, we are representing in terms of impedance. So instead of R, we are representing Z. So thus the 3 elements will have the following impedances. So impedances of resistor, Z of S is equal to R. Impedance of the inductor, Z of S is equal to S times L. Impedance of the capacitor, Z of S is equal to 1 divided by SC. So inductor means always S times L. Capacitor means it's always 1 divided by S times C. So these are the impedances value in S domain. This is also another important equations that you have to remember. And admittance. What is admittance? Admittance in the S domain, the admittance is also simply the reciprocal of the impedance. So Y of S is the representation. You can represent the admittance in Y of S. It's just the reciprocal of the impedance, 1 divided by Z of S. So Z of S is, we know already, V of S divided by I of S. So 1 divided by Z of S means what? I of S divided by V of S. So I of S divided by V of S. So use of the Laplace transform in circuit analysis facilitates the use of various signal sources such as impulse response, step response or unit response, ramp response, exponential, sinusoidal. So whatever the signal sources, we can represent everything in Laplace domain. So, and then circuit analysis using the S domain to analyze the circuits is relatively easy. Converting from time domain into S domain results in complicated equations based on derivatives and integrals into a simple multiples of S and 1 divided by S. So instead of using so many complicated, if you use the simple mathematics, then the equations will be more complicated and longer to solve. That's why we are using these Laplace transforms. Once you use the Laplace transforms, then you are just going to have a simple equations with multiplied by S or 1 divided by S. And it needs need only using algebra to set up and solve the circuit equations. You're just going to use only algebra. and all theorems and relationships developed for DC network in the S domain. So of course, everything is already developed and introduced by scientists. So just we are going to study how to use those developed relationships. So now again, we are studying about the transfer function. The transfer function is a key concept in signal processing because it indicates how a signal is processed as it passes through a network, because transfer function is equal to output divided by input. So the transfer function relates the output of a circuit to a given input, assuming zero initial conditions. So H of S, that is the transfer function, is equal to Y of S divided by X of S. So if this is the system, so you are applying Y of A, X of S, and then you are getting at the output Y of S. Then the transfer function H of S is equal to output divided by input Y of S divided by X of S. Okay, so this is the transfer function. The transfer function is very important. And the transfer function, there are 4 possible transfer functions. For example, in the voltage domain, VO of output voltage divided by input voltage. So VO of S divided by VI of S. The same, this is the voltage gain. So we are writing with respect to voltage, output voltage divided by input voltage. If we talk about current gain, then we talk in terms of output current divided by input current. So IO of S divided by I of S. And impedance, when we talk about impedance, that is a V by I. VO output voltage divided by input current, that is the actual definition of the impedance. And when we talk about the admittance, that is the IO divided by VI. That is the output current divided by input voltage. So we can write the transfer functions in 4 different ways. Please see here: voltage gain, current gain, impedance, and admittance. We mostly use these 2 and this one. A single circuit may have many transfer functions if you represent in terms of voltage or current or impedance. So each corresponds to specific choices of input and output. So if you are only considering output voltage and input voltage, you will get this kind of transfer function. If you consider only output current and input current, you will get like this, current gain. If you consider output voltage and input current, then it will be impedance, and so on. So now you know the transfer function. Each transfer function can be found in 2 ways. The first is to assume any convenient input, then use any circuit analysis technique. That is the current or voltage division or node analysis, as I mentioned. This is from the network theory part. And then you find the output. Once you know this input and the output, then it's easy to take the ratio and find the transfer function. And now I think we are ready to jump into the problems. How to solve the problems. So to solve the problems, you must know all these basics. So we can calculate the transfer functions in different ways. And what is the transfer function? And here you should know what is the impedance, how to calculate the impedance, and how to calculate the admittance, and zero initial conditions, how can we represent the resistor, inductor, and capacitor in the S domain. And what is the equivalent circuit of the capacitor in time domain and capacitor in the S domain. Similarly, what is the equivalent circuit of inductor in time domain and S domain? And what is the equivalent circuit of the resistor in time domain and Laplace S domain? So please try to go through this and we will solve some problems and then we will finish the Laplace transforms.